As we get started today on our Math 1109, Chapter 10.2, Fractional Exponents, I'd like to introduce this name, Jaime Escalante. And this is a picture of him. He was born in Bolivia, and he was famous for being the teacher they illustrated in the movie Stand and Deliver, in which he took a bunch of East LA kids that weren't thought to be pretty good at math, but through his coaching and the program he instituted in the schools, got a lot of these East LA students to pass a college algebra test there, the AP, Advanced Placement Test in Calculus, which is a challenge for anyone. And one of the statements he would always say is, you have to have ganas. Ganas is desire to want to get something accomplished. So when you look at the area of math, again, I know for many of you this is an area that's quite challenging. And one of the trademarks of Jaime Escalante is he always wore a cap. Well, I didn't have a white one, but I have a black one. He's passed away now. He died in 2010, so 3 years ago. But today I'd like to honor him. I'm going to wear this cap in his honor. Jaime Escalante. Look him up on the internet. I think you'll be impressed. Now, as we look at fractional exponents in our chapter on radical expressions, this, you recall, is the radical sign, and this underneath the radical sign is the radicand, and then over here we had a little index number. Well, there is a way to show this radical expression in terms of fractional exponents, because what I have here is equivalent, that the square root of 4 is equal to 4 to the 1/2 power. Now, how can we translate that a little bit? Well, when you think of a fractional exponent like 1/2, the denominator of that fractional exponent is actually the index number that we don't write. And right here, the numerator of that fractional exponent is written like that. So 4 to the first power, and then the second root of 4. That's another way of writing a fractional exponent in its other form, a radical expression. So if you were to do this, the square root of 4 or 4 to the 1/2 power simplified is 2. So now we get to do some examples. Now, key to this next one is 81 is to the 1/2 power, not the negative sign. So when you convert this, this becomes, again, radical sign. The second root is there. 81 is there to the first power. And now to the outside you apply the negative sign. So the square root of 81 is 9. And you apply the negative sign, negative 9. Again, the key is when you have an exponent, it applies to the base. And the base is 81, not the negative. Now, if you have something in parentheses, then that's a different story. Okay, converting number 2 now to a radical expression, this is going to be the square root, there's our square root, our denominator of our fractional exponent, and then it goes 25 over 36. Now, where do we put that exponent? Well, we could put it here, but the preferred place to put it is out there. So it's saying that all of this is raised to the third power, and you're using the denominator of the fractional exponent to indicate your index number. So now we have the square root of 25 is 5. The square root of 36 is 6. And then that will be now raised to the third power. So equals 5 times 5 times 5 is 125. And 6 to the third power, you have to put that in your calculator. I don't know that one offhand. Okay, so now that you have an idea of how to take a fractional exponent and make it into a radical expression, then that's basically what you're going to do. So you're going to say here the square root of 9 x to the 10th power. So converting it from its fractional exponent form to its radical form, then this is just going to become 9, this should say 3. And then divide this by 2, x to the 5th. For number 4, there are no perfect fifths in there, so we're just going to convert it to radical form, the 5th root of 3m. And if it's to the first power, we don't write anything. And this one will be the 3rd root. Again, we take our denominator as our index number. And you can actually leave it in parentheses like this. That would be okay. All right, now we're going to deal with negative fractional exponents. Well, the same techniques apply. This is going to become 1 over 9. Now, below the division bar, the exponent becomes positive. And then this becomes 1 over the square root of 9 to the 3rd. Now, square root of 9 is 3, and 3 to the 3rd power is 27. Now this becomes 1 over 25 to the 5/4, and this becomes 1 over the 4th root of 25 to the 5th power. And here, when the negative is in the denominator, we just move this up to x to the 1/3 power, which becomes the 3rd root of x. Oh. Remember, the denominator of your fractional exponent is your index number. Now 10's a little tricky. It'll be 4. Now what goes up to the top is only the base, which will be y to the 2/3 over 7, which then becomes 4 the cube root of y, and you could put the square in there, that would be okay. And then that's all over 7.